The Fundamental Theorem of Calculus, Part 1, the chain rule extension. This has become a very important part of the course. The Fundamental Theorem of Calculus, Part 1, if you recall from earlier in the unit, if I have g of x equals the integral from some constant a to x of f of t is the dummy variable dt. If I have that, then a consequence of it is that g prime of x is equal to f of x. Now the extension. Suppose I had g of x is equal to the integral from still some constant a, but no longer just x, but some function of x. Let's call it u of x, f of t dt. Then we employ the chain rule, and so g prime of x is equal to f of u of x times du dx. Now that takes a little bit of wrapping your mind around. The execution of this is pretty simple, but getting you to understand why it works is a little bit tricky, and that's what I'm going to spend a good part of this lesson doing. In these next three examples, I want to spend the time basically showing you the end of the story, what you ultimately need to be able to do. I'm not saying you'll be able to understand it yet, but this is a simple what you need to be able to do. So in number one, the g of x is the integral from 2 to x squared of sine of t dt, and ultimately the thing we want to find is g prime of x. What this is going to end up doing is it's going to take this bound and it's going to plug it in for our dummy variable. When we do that, we have the sine of x squared. And then this du dx portion, the chain rule portion, means I have to find the derivative of this bound that is not just x, but some function of x. And the derivative of x squared is 2x. And that's how it ends. G prime of x equals the sine of x squared, and then times 2x. So let's take a look at the second one. I'm going to try to make this seem easier and easier each time, because what you're actually doing is pretty easy. So for number 2, we're going to say g prime of x. See if you can beat me to it here. I'm going to take the natural log of x and substitute it in for the t, and that gets squared. And then I finish this with the derivative of this upper bound, which is 1 over x. All right, let's take a look at number 3. G prime of x equals the sine of e to the power of, here's where I do my substitution, 5x squared. And then I finish this off with the derivative of stuff, which is going to be times 10x. Let's do another more general one. Suppose g of x is equal to the integral. I'm going to pick any number. Let's say -3 to, let's go 5x cubed. And then I'm going to just generically say f of t dt. Derivative, g prime of x equals f of the 5x cubed, and then we finish off with the derivative of stuff, which is going to be 15x squared. So pretty easy to do. We're going to verify because you probably wrestling a little bit with how the chain rule works in this circumstance. Again, how the dummy variable converts back into the regular variable. So if we verify this, I think it will answer a lot of the questions. Please note that verification is not something I want you to do. It's just something for you to understand why it was so easy to do these 4 above. Okay, so in my verification process, the first thing I'm going to do is expand by doing the fundamental theorem of calculus. So in that case, I need the antiderivative for the sine of x, and that antiderivative is negative cosine. I said x, but I meant t. Negative cosine of t. And then we will take that from 2 to x squared. Now I plug in the top bound first, so negative cosine of x squared minus a minus cosine of 2. All right, so that's what g of x expands out to be. So now when I find g prime of x, I will take the derivative of this term, and the derivative of that term becomes minus a minus, so sine of x squared, and then our traditional chain rule times 2x. That was the derivative of this term here. And then the derivative of cosine of 2, well, cosine of 2 is just a constant, so that derivative is going to go to 0, and then we see that we have the sine of stuff times the derivative of stuff. So this verifies with that. Let's do another one so you can get the hang of it. Number 2. Okay. Let's expand this one like we did the previous one. So the antiderivative of t squared is t cubed over 3. And we will do that from the lower bound 5 to the upper bound natural log of x. Fundamental theorem of calculus, part 2. That's going to be the natural log of x cubed over 3 minus 5 cubed over 3. So that's the expansion. Let's do the derivative now. G prime of x is equal to, we need the derivative of this portion. 3 comes down as a coefficient and cancels out with the denominator, so we have natural log to the power of 2 times the derivative of stuff, 1 over x, minus 0, because the derivative of the constant is 0, giving us natural log of x squared times 1 over x. And that should verify, yes it does, with what we have above. In example 3, we cannot verify it. We talked about this earlier in the unit because the indefinite integral here is not integrable, so we don't verify it, which is not something I want you to ever do anyway, the verification. We just rely on the theory. I'd like to present another example here, example 4, g of x equals. Now you'll notice this time the variable bound is in the lower bound, and I would like you to think for a second what we might do because of that. See if you can determine the answer right now, g prime of x. All right, so this answer will be negative cosine x squared times 2x. Now, why is that? All right, so if I write the g of x differently, if I flip the bounds and make that from 2 to x squared cosine of t dt, then when we employ this fairly easy chain rule, the negative is negative, cosine, we plug in the x squared, and then we multiply it by the 2x. I would like to verify this one. Again, this is the end result. Please don't do more than this. I want to verify it just for you now at this moment so that you can wrap your mind around it. So let's go g of x equals the integral from x squared. I'll leave it on the lower bound, cosine of t dt. I'll expand this. The antiderivative of cosine t is sine t, and we will take that from x squared to 2. This time we plug in the 2 first, sine of 2, minus, there's where the minus comes from, the sine of x squared. So that's the expansion, and then when we take the derivative of it, the first term has a derivative of 0. And then we have the negative, then we have this derivative, which is going to be the cosine of stuff times the derivative of stuff. And that indeed checks out. This next one is pretty important, and I would like you to give it a try before I write the final answer. The thing I want you to try to find is g prime of x. Okay, I slowed down. See if you tried it. Okay, if I find g prime, I have to find the derivative of the first term, and then I have to add it to the derivative of the second term. So the derivative of the first term is this traditional 9x squared plus. Now I'm doing the derivative of the integral, and we employ our new chain rule here. So it's going to be f of 4x squared times the derivative of stuff, which is 8x. So here we didn't have a specific function, but it was more represented generically, and I have recognized in the AP exams that they're doing more and more of this type of analysis. Now, this part of the lesson concludes with asking you to find dy dx for each of these four. And while I'm writing this down, I would like you to attempt to complete all of them and then maybe press pause before I go over the answers, because I want you to do it. I don't want you to verify, I just want you to find the derivative. Okay, here we go. The first one is as simple as plugging x in for t. Now, if you always want to do the chain rule, you would do the derivative of x, which is simply times 1, and that does not change the expression's value. Number 2, that's going to be e to the power of, I plug x squared in for t, and then notice that the t got squared, times the derivative of stuff, times 2x. In the next one, I can see that the x is in the lower bound, so it's going to be negative, and then natural log 1 plus x gets substituted in for the t, and then the derivative of stuff is simply 1 again. In the final problem, it's going to be negative, lower bound, cosine x cubed over x cubed squared plus 2, and then I need the chain rule, the derivative of stuff, which is 3x squared.